to post it up later, okay? So good morning, everybody. We're almost halfway done with summer school, if you believe it or not, all right? Summer school is actually 22 days long. Today is day 10, tomorrow is day 11. So we're already almost there, right? We finished the first unit yesterday, so ideally we're all caught up with the first 4 mastery tests. We're starting our second unit, and we're only doing 2 units for the summer, right? So our second unit is all about expressions and equations. We're gonna go over what that means today exactly. There's a real small difference between expressions and equations. And then we're starting with the work for the first lesson. That's gonna deal mostly with exponential expressions, but then also get into things like the order of operations. All right, so ideally, hopefully this is a review for you. It's not too difficult, but I do find that especially working on things like order of operations, this is stuff that a lot of students tend to make mistakes with, especially going up to higher level math classes. So the faster you get it down, we're getting to practice this now, the better you're gonna do later on, all right? So let's just first start by seeing what the objective for today is, right? It says that our objective is, in this lesson, you will write and evaluate numerical expressions involving whole number exponents. So we're doing 2 things. We're gonna work on first writing. So we're gonna see a written scenario, and we need to write out some type of numerical expression to represent it. And then also we need to evaluate a numerical expression, right? All that means evaluate is do the math. So if I gave you something like 4 plus 5 and said evaluate, you would say 4 plus 5 is 9, right? That's what it means when you're evaluating an expression, right? Simple. So to start, they're giving us a scenario that is totally relatable because you guys all in your spare time change out windows, right? I know. So let's just read through this and let me try to explain what they're going for here, right? But the idea is that we're talking about exponents. It says, Tyler is installing window shades in his new home. He also wants to get the windows cleaned. Before the cleaning company can tell Tyler how much it will cost to clean the windows, it needs to know the total number of window panes, right? So this is the information that he needs to figure out. How many window panes does he have in his house, right? It says that there are 12 windows in all, each with 4 window panes across and 4 window panes down, right? So let's try to imagine what his house looks like, all right? I'm gonna draw on the screen for a little bit. So it says that he has 12 windows. So I'm just gonna draw one of those windows, right? Let's say this right here is one of his big windows, right? And he's got 12 of these windows, right? It says that each has 4 window panes going across and 4 window panes going down. So if I want to figure out how many window panes he has, it's going to be 4 going to the right, going across, right? So imagine 1, 2, 3. Imagine these are squares, 4 going across and 4 going down. So 1, 2, 3, 4. And then this would just continue the whole way. So we have 4 going across, and I apologize. I did used to draw when I was a kid, but I'm obviously out of practice, right? This is his very horrible window. It's got 4 window panes going across, 4 going down. So it says the total number of window panes is given by an expression, right? An expression is just when I write math out. So I could say something like, 3 plus 2. That's a mathematical numerical expression, right? With a whole number exponent. So we're gonna get to that in a second, right? So figuring out here, how many window panes do I have here? Can somebody tell me in the chat? For just this one particular window. How many boxes do we see there? Right? We can count them out. We could say, okay, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So I can see right here that over here, each window has 16 panes inside it, right? 16 window panes. Now, another way that I could figure that out, instead of just counting it up one by one, is we can multiply, right? So this is kind of like finding the area of this box here, right? And I see, good job, Kevin, over here. This is 1, 2, 3, it goes 4 down. It goes 4 across, so this is like finding the area. 4 multiplied by 4 is going to give us that same 16 that we counted up, right? So let's see what the next slide has for us. Right? So now they're going to start introducing exponents. And again, just if this gets confusing at all, let me know so I can stop and re-explain it, okay? It says each of Tyler's windows has 4 squared window panes, which means 4 times 4. So what they're telling us here is this expression 4 squared means the same thing as 4 times 4, right? I'm going to write that on the side over here. So 4 squared, this here, 4 with that little 2 up top, is read as 4 squared, right? So 4 squared is equal to 16 is what that's telling us there. Because we already counted up on that last page, and we know that it should be 16 there, right? So it says the expression 4 times 4 can be written as 4 squared, or 4 raised to the power of 2. There's a couple of different ways that you can write it. You can say this is 4 squared or 4 to the power of 2. People are going to read it different ways. It means the same thing, right? But in essence, what this means to us is it's kind of a recipe. It's telling us what to do with the numbers. So all that 4 squared means is it means take the number 4 and multiply it by itself 2 times, right? I can see right here that I have 2 4s. So it's kind of shorthand notation for when you have a lot of things that you're multiplying together. So for example, right? Let's say, I'm just gonna go to a blank page so I don't have all this other stuff here. Let's say that I had something like, let's say I have 2 plus 2 plus 2 plus 2 plus 2 plus 2, right? The number is small, so you can just keep on adding 2's. But we know in math that repeated addition is the same as multiplication. So I say, okay, how many 2's do I have here? I have 1, 2, 3, 4, 5. I have 6 2's, right? So a simpler way of writing this would be to say, okay, so 6 multiplied by 2. They both give you the same thing. So the same thing is true when we talk about exponents. If, for example, I had something like, say, 4 times 4 times 4 times 4 times 4, right? The way that it works is now instead of addition, I have multiplication. So I don't know why this is so sloppy. I'd say, okay, how many 4's do I have here? I have 1, 2, 3, 4, 5. So in this case, I have 5 4's. So if I wanted to re-express this with exponents, I'm going to say, okay, so the number of things that I'm multiplying 4 5 times. So this expression here is equal to 4 to the power of 5, or 4 to the 5th power. And like I said on this slide, this over here, this number in the bottom is called the base. This number right here is called your exponent, right? Hopefully this is a review for you guys. And it's just a simpler way of rewriting something. So going back to the last expression, right? We said, okay, so he has 4 going across by 4 going down. So 4 times 4, a simpler way to write that would be 4 squared, right? And you might say, Mr. Correa, that really doesn't look that much simpler. 4 times 4 versus 4 squared, right? Sure, you're saving just writing that x there, but not much. But exponents do come a lot more useful when you have multiple things, right? Let's say I had like 50 4's written out here. You wouldn't want to write 4 times 4 times 4 times 4 times 4 out 50 times. So instead, you would do that with an exponent, right? And that's why we have exponents in math, is for situations when we have those numbers that are a lot bigger, right? You won't necessarily always use them for small cases like this, but these are just examples to start out with. So then once we get to those larger numbers, you're more comfortable dealing with the exponents already. All right, so any questions before I go on with the rest of this part here, please let me know. All right, I'll give you guys a second. right? They give us this example down here, 6 times 6 times 6. You could write as 6 to the power of 3. You would also say 6 cubed, right? So kind of like how this one is 4 squared. If it's to the third power, it's cubed, right? Now, some other things to note are just special cases, right? So we do have a couple of special cases where you have exponents of either 0 or 1. And it's pretty simple, right? Basically what this is saying right here is anytime you raise something to the power of 1, it stays the same. And for now, just take these things as facts, try to memorize them. Once you get to like 8th grade math, once you get to 8th grade math, you kind of learn why these rules are the case, right? But for now, we're just gonna take them as fact. So if I had something like, say, 7 to the first power, that's just equal to 7. If I had something like 17 to the first power, that's equal to 17. So kind of like when you multiply something by 1, it doesn't change. Same idea here with an exponent, right? Even if I had something like you can have negative bases, I could have -1 to the power of 1. Again, that would still be equal to -1. I could even have a decimal. I could have something like 7.4 raised to the first power. That's equal to 7.4. And if you think about what we said exponent means, that should make sense. Because what this is really saying, that's like saying, okay, so I'm taking the number 7, I'm multiplying it by itself once. So I really only have 1 7. I'm not multiplying it by anything else because it's not something that's bigger than or equal to 2, right? So that's how it works when we're dealing with the number 1. When we're dealing with the number 0, right, it's not too different. So there is another rule that is a little simple to remember. The reason why, just don't worry about that. Again, you'll learn that in 8th grade math. So if I had something like, say, 5 to the power of 0, it's always going to be equal to 1. So anytime you raise something to the 0 power, you get 1. I can take the number 7, please stop moving this, and raise to the power of 0, I get 1. I can take like the number 10, raised to the power of 0, I get 1. I can take the number 5. I already wrote 5, so let's say 15. 15 to the 0 is equal to 1. So anything raised to the power of 0 is always equal to 1, except you only have one exception. You can't do 0 to the power of 0, right? If you try that in your calculator, you're going to get an error. That is just undefined, right? Same reason why you can't in math, if you try to do 0 divided by 0, that is also something that is undefined, right? Just things that you can't do in math, things that don't make sense, right? Besides that one case, everything else follows this pattern, right? Even over here, even if you had 0 to the power of 1, that's equal to 0, right? The only thing you have to watch out for is when you have 0 raised to the power of 0, but you're really not going to encounter that in 6th grade math. That's just more something of you to be aware of, right? But just try to remember these in case they pop up. Something to the first power is itself. Something to the 0th power is equal to just 1, right? Not 0. Again, please stop me if I'm going too fast. Let me know if you have questions, right? So next thing is talking about writing a numerical expression, right? Another thing, sometimes people, instead of saying a numerical expression, you might see some weird people call them something like a number sentence. Numerical expression, same thing, right? The idea is that in ELA, right, in English, we use combinations of letters to make words and to make sentences. In math, instead of using words, we have numbers, and we put these numbers together to make number sentences, which are what we also call expressions, right? Now, what we're going to get to later is the difference between an expression versus an equation. Does anybody know what's the difference between an expression and an equation? I'll give you guys a second to let me know if you think you do. Anthony, you got your hand up? Okay.
The difference between an expression and an equation is, I believe an equation, you put an equal sign. Yeah, I believe with an equation you put an equal sign
Right.
for the total after you
Exactly. Good.
after you find like the product, and an expression seems to be the other way around.
No, you got it right. So an equation, right? And Kevin, I see also got it in the chat. Equation has to have an equal sign in it. So if you look right here, right? EQA looks like equal. So anytime you're talking about something being an equation, it would need to have something like, say in this case here, equals. Now, when we get to algebra, you might have a variable. You might say, okay, like equals X. Or if we're just being simple and looking at this here, 15 plus 4, I know is 19 minus 2, 17. So if I have equals 17, that makes this here an equation, right? Without this equal sign though, it's an expression instead of an equation, right? So just some technicalities to be aware of, because especially when you get to things like state testing, sometimes they'll ask you for an expression, sometimes they'll ask you for an equation, and believe it or not, if you do not put an equal sign and they ask you for an equation, you will lose points. So that's the main idea for understanding that difference there, okay? So over here, we have some expressions, and again, they just don't have equal signs. But I can still do the math there, right? If I wanted to evaluate this expression, you follow the order of operations, which we're going to go on into a second, right? So it says that they can also be written in words. So I could write something out like 9 times 6 minus 11, or I could write 5 divided by 10 plus 2, right? And there are also some exercises where you have to work with taking an expression written in words like this here, 9 times 6 minus 7, and translate it into an expression with numbers. I don't think that's what we're doing today though, right? But for this example, I would say, okay, so 9 times 6 minus 7. That's how I would rewrite this in words here using numbers, right? And they mean the same thing. So over here for this example, they're saying, look at the expression 56 divided by 7 plus 5 times 5 times 5, right? So this is going back to what I said before about how exponents are really meant to make things easier. So instead of taking this whole part here and having to write out 5 times 5 times 5, right? Let's say that you're writing a paper and you had to keep writing this out, right? After a while, you're going to be tired of writing 5 times 5 times 5, and even more so if you had like 10 5s there. So instead of doing that, we would use the relationship that, okay, I have 3 5s here, so my exponent is 3, the base is 5. A simpler way of writing that would just be writing 5 to the power of 3, right? So basically, they take this expression here and rewrite it, replacing this 5 times 5 times 5 with just this 5 to the power of 3, right? So you can see here, this takes up less space. It would be a little bit easier to write, right? And again, that's even more apparent, right? The simplicity of exponents, the more digits that you add on, right? The more times that you're trying to multiply. So in this example over here, we see 2 times, 3 times 3 times 3 times 3 times 3 times 3. Again, even more things to write down. So instead of doing that, you can really simplify this whole thing here by writing 2 times 3 to the power of 6, right? And you can see that that takes up a whole lot less space. So that's really why we have exponents in math, is to simplify things, right? Especially once you start looking at, if you guys ever take like a physics class or a course where you're looking at things in space are extremely big, right? Things are really far apart, like the size of a planet, the speed of light, the distance from the sun to the earth, right? Those are all extremely large numbers. So if you were to write those numbers out, it would take up a lot of space, and we use something in math called scientific notation, which takes advantage of these exponents to make writing those numbers a lot simpler, right? But that's what you're gonna start getting into in 8th grade math, scientific notation. Look out for that, all right? Again, please let me know if we have any questions. I believe next we're going to start reviewing the order of operations. Actually, okay, so first we're going to write some expressions. So let's read this scenario here. It says, let's write a numerical expression that represents a real life situation. It says, Uncle Bob gives Jeremy, Joe, and Joanna each 4 boxes of cupcakes for their party. Each box has 4 cupcakes. We'll write an expression for the total number of cupcakes from Uncle Bob, right? So again, we have a box of cupcakes. The box has 4 cupcakes inside of it, and they each get 4 boxes, right? So let's see. Again, it usually helps to draw this out. So let's just draw Jeremy, right? So let's say this is Jeremy. How many boxes of cupcakes does Jeremy have? Right? It says that each of them has 4 boxes. So Jeremy has 4 boxes. 1 box, 2 boxes, 3 boxes, 4 boxes. And inside each of these boxes, he has 4 cupcakes, right? So this box here has these circles are my cupcakes. 4 cupcakes, 4 cupcakes. So if I wanted to figure out how many cupcakes Jeremy has, I know that I have 4 boxes. Each box has 4 cupcakes. So that would simply just be 4 times 4, which we know is, no. I'm using that local. Get another one from the room, please. 16, I'm using that one too. Grab one from the room, Penelope. 4 squared, right? And then all I need to add on to that, we usually finish at the same time every day, 9:30. So 4 times 4 is equal to 16, or 4 squared. So they're trying to focus on us using these exponents today. Now I'd say, okay, how many other people do I have? So we have Jeremy, Joe, and Joanna. They're all getting the same thing. So one way to think about it is that I could say, okay, so this is Jeremy, this is Joe over here, this is Joanna, right? Each of them have 16. So if I want to figure out how many cupcakes we had all together, I could say 16 plus 16 plus 16, right? Or, right, another way, 16 times 3. I'm writing it like this because they're trying to emphasize the exponents today, right? Kevin said, okay, another way that we could write that is 16 times 3, because I have 16 3 times, right? Now, similarly, another way that I could write this here with the exponents is say, okay, I have 4 squared 3 times. So I could say this is the same thing as saying 4 squared times 3, because this is here is written 3 times, right? 4 squared times 3, what that means is just to take this number here and add it 3 times, right? 4 squared plus 4 squared plus 4 squared. Over here, they have it written in reverse, 3 times 4 squared. But just remember, in math, there's a property called the commutative property. So multiplication is commutative. What that means is I can swap the order of these. So 3 times 4 squared is the same as 4 squared times 3, right? Addition and multiplication both have that commutative property where you can swap the order of things. So don't get confused just because you see things written differently, right? Sometimes I might do this on a multiple choice test where you got your answer as this, but you see it written as this, and you just have to remember that property in order to get it right. If you're looking for this and you don't see it, try looking to see if they have the reverse of it there. And I appreciate people that are just writing in the chat answers as they get them. All right, so let's try this next question here together. It says, Bella, Tia, and Ron participate in a trivia contest at a bookshop. Tia scores 4 points, Ron scores 3 points, and Bella scores 2 points. Each player gets a number of paperback books equal to the square of the points he or she scores. What is the total number of books the players receive? All right, so I'll give you guys a second to think about this one here. And I usually find with these, it's easy to just write things out, right? So let's say I have Bella here, right? That's your name, Bella. I've got Tia. I don't think we have a Tia or a Ron. Let's start with what we see here, all right? So it says, all right, I see people writing some answers out there. Good. It says Tia scores 4 points. So Tia has 4 points. Ron scores 3 points. So this is why it's helpful to write things out just so that you don't mix things up, right? And it says Bella scores 2 points. It says each player gets a number of paperback books equal to the square of their points. So all I have to do now is square each of these numbers. So remember what that means is I'm just going to write this, and you can notice, look at your answer choices, right? My answers are written in squares, so it wouldn't make it easier for me to just multiply this, right? I might say, okay, so I know 2 squared is 4. I know 4 squared is 16. I know 3 squared is 9, right? That's not going to help me here because I'm going to say, okay, I don't see those numbers there, right? So let's backtrack and say instead, 2 squared is just 2 squared. 4 squared, I'm going to write 4 squared. 3 squared, I'm going to write as 3 squared. That's it, right? And to figure out how many books that they all get together, I just need to add these all together. So this here is a mathematical expression, right? But now I'm going to say, okay, I'm looking at my answer choices, and I don't see this answer choice anywhere here. So what did we do wrong here? Did we do something wrong? Or does anybody see the right answer here somewhere and we're just not seeing it? So to make it easier to reference, let's say this is number 1, 2, 3, or 4. Does anybody see an answer here? Okay, so I'm seeing Kevin saying 2, right? So let's look at 2. 2 says 4 squared plus 3 squared plus 2 squared, but that's not the same thing as what I have here, right? So how could that be the answer? Okay, so I'm seeing somebody else saying 1, so 4 squared times 3 squared times 2 squared. So let's look at the difference between these two, right? This one uses multiplication. This one here uses addition. Now, these over here, right? These can't be right. If I look here, this has 2 to the power of 4. This also has 2 to the power of 4, but all these have exponents of 2, right? So it's definitely not 3 or 4. And a lot of times with multiple choice, you can do it by process of elimination. I'd say over here, right? We were trying to figure out what's the total number of books that the players received. So if Bella got this many, Tia got this many, Ron got this many, we actually needed to add the numbers up. And good, right? That's why you're going to be careful because a lot of times if you're just being quick, you might say, okay, I see the answer. You want to look closely at math because you might get thrown off just by a simple sign, all right? So this one here has the multiplication, but we're using addition, so that tells us that the answer should be number 2, all right? But now let's see over here, right? I had 2 squared plus 4 squared plus 3 squared. This here is saying 4 squared plus 3 squared plus 2 squared. So my question is, are these two expressions the same thing? Do you guys think that they're the same?
No.
Right? So they are written differently, right? But do you think we're going to get the same result if I did these? So let's see right here. 2 squared is equal to 4. 4 squared is equal to 16. That's equal to 9, right? If I add up 4 plus 16, that's 20 plus 9. That's going to give me 29. If I tried it down here, 4 squared is 16 plus 9 plus 4. 16 plus 9 is 25 plus 4 gives me 29. So these two actually give me the same result, all right? And what Anthony said in the chat is that they're the same, they're just formatted differently, all right? And again, this brings me back to what I explained on that last page. It's called the commutative property. So kind of like when we talk about somebody that commutes to work or somebody that commutes to school, sorry, I can't spell while I'm speaking. Commuting means moving from one place to another place. So in math, when I have positive numbers, I can commute them, right? So 2 squared plus 4 squared plus 3 squared, I can rearrange these numbers however I want and still get the same answer. So all we have to do is figure out, okay, am I adding up the same 3 things? So I say, okay, so I have a 2 squared here, I have a 2 squared here. I have a 4 squared here, I have a 4 squared, I have a 3 squared, I have a 3 squared. So I'm adding up the same 3 numbers. I'm gonna end up with the same result, right? That's how the commutative property works. Good job if you guys got this one right on your own. Just remember, be careful, look at your signs carefully, right? They're gonna try to mix you up sometimes with addition signs and multiplication signs, right? But pretty good job overall, guys. So next page is gonna start us getting into what we call the order of operations, all right? So when you're performing different operations, it's important to have a strategy on how you're gonna multiply those things, right? In math, we actually have to do things in a specific order in order to end up with the correct answer, all right? So it's giving us this expression right here. It says the expression 5 plus 6 multiplied by 3. All right, let me just highlight that because that's what we're working with first. So it has 2 operations here, right? It has the operation addition and it has the operation multiplication. So if you were to do the addition first, right? Let's say in this case, you did 5 plus 6 first, and then you multiplied by 3, you're gonna get 1 answer, all right? So if I first did 5 plus 6, 5 plus 6 gets you 11, 11 times 3 gets you 33, right? That's one result. But if instead I did the multiplication first, right? I did 6 times 3 first, 6 times 3 gives you 18, and then if I added the 5 on, I would get 23, right? But those two are different results, right? So math is about rules. It's about order. It's about just kind of following the rules to get the answer. So it can't possibly be that 5 plus 6 times 3, it can't have 2 answers, right? It's either equal to 33 or it's equal to 23, right? It can't be equal to both of them, right? That would be like, that would just cause a lot of problems in life. If math problems could have 2 different answers, because math is a lot of times involved in money, right? So if you were doing some problem that involved money, you would obviously want to get the result that gave you more money, but you might end up with less money if this was the case, that you could possibly get 2 different answers, right? Okay, good. So I'm seeing Kevin said that if anything is in the parentheses, that's telling you to do that first, right? So we're gonna start getting into how we actually figure this out. So does anybody actually know, before I get into that, which of these 2 approaches was correct? Is 33 the right answer, or is 23 the right answer for this question here? 5 plus 6 times 3. What do we think? 23 or 33? Okay, so the correct answer is 23 there, Kevin, and we're gonna explain why that is on the next page, all right? So in math, we have something called the order of operations, all right? So an acronym that you can use to remember the order of operations is please excuse my dear Sally, right? So the acronym is PEMDAS, right? And each part stands for something. So P just stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A is addition, S is subtraction. So the idea is that you work your way from the left-hand side to the right-hand side. Any parentheses that you see first, you do that first. Then any exponents that you see, you do that next. Then any multiplication or division, you do that next. And then addition or subtraction, right? So this picture here is actually a really good picture to help you remember PEMDAS, right? You can see that the P is by itself. We can see that the E is by itself. And then you see this one block here where the M and the D are actually together. Same thing over here. The A and the S are actually together. So actually at some point in schools, they stopped teaching PEMDAS because it was confusing students, right? A lot of times what students see is they say, okay, so parentheses, exponents, multiplication, division, addition, subtraction. So sometimes students would think, okay, you have to do all multiplication before you get to doing the division, right? But an easier way to write this is you should actually write it like this. So parentheses, exponents, multiplication and division are at the same level. And then addition and subtraction are at the same level, right? So you do whichever one you see first, coming from the left to the right. If you see multiplication, you're going to do that. If you see division first, you would do that. But you don't have to always do all multiplication before you do division, all right? It's always left to right, whichever one comes first. So again, these two are at the same level. These two are at the same level, right? And I'm going to show you guys a problem tomorrow that kind of explores this here. And if you're always trying to do the multiplication first, you will sometimes get the question wrong. So just remember, it's multiplication or division. All right, just give me 1 second. So again, please excuse my dear Aunt Sally. That's how we try to remember this here. And let's just walk through this example here. So they're giving us the problem 10 plus 2 multiplied by 5 squared. And the steps are written out here, but I'm just going to work it out over here. So 10 plus 2 times 5 squared. So again, parentheses first. So I see 10 plus 2 gives me 12. So I'm going to rewrite this portion as 12 plus 5 squared. Second, I look to see, do I have any exponents? Yes, 5 squared. So the next thing is 12 plus 5 squared is 5 times 5, which means 25. Then I say, okay, do I see any multiplication here? No. Do I see any division? No. Do I see any addition? Yes. All right, so 12 plus 25 is going to give me 37. Wait, sorry. That was a multiplication, my bad. Multiplied here. All right, so 12 times 25 instead should be 300. Right, the way I did that is I think about quarters. So 4 quarters makes $1. I have 3 groups of 4, so 300, right? Yeah, 9:30 is when we finish with these sessions every day. All right, this lesson today is just a little bit longer than normal. Usually we finish early and have some time to practice at the end. Right, any questions on this one here? And we're gonna get a lot more opportunities to practice this. Tomorrow I'm gonna give you guys some more practice, okay? So again, let's go work through one more example together. The steps are here, but I want to show it out from you from scratch, okay? So 16 divided by 2 plus 5 times 3 times 2 squared minus 3, right? So again, work out the operation. So what we're going to do first is we're going to do our parentheses. So I see one set of parentheses here, right? What I'm changing, I'm going to do in red. So I have 16 divided by 2, whatever I'm not changing, I'm going to keep writing there, plus 5 times 3 is 15. Multiplied by 2 squared minus 3, all right? Sorry, let me switch over so it's easier to see. Okay, so now next we have E, right? Whoops. And this will be the last example before we leave. Sorry, something's going on here. Okay. So next thing is E. Do I have any exponents here? Yes, I have this 2 squared. So 16 divided by 2 plus 15 times 2 squared. 2 squared is 4 minus 3. Now, next one, 16 divided by 2 plus 15. The next step is to see, okay, I did parentheses, I did exponents, right? Again, be careful. It's multiplication or division, right? So pay attention to this part. When you do this, you work from left to right and do any multiplication or division that you see first. So left to right, first I see a division sign. So 16 divided by 2 here is going to give me 8. So this here is going to be 8 plus, now I have 15 times 4. So I'm going to multiply this out. 15 times 4 is going to give me 60, right? So plus 60 minus, I'm just going to leave it in red, 3. And now I do my addition or subtraction. So again, same thing, left to right, add first or subtract. So 8 plus 60, I'm going to just write this out here, is going to be 68 minus 3 is going to give me 65, right? So that's the final answer there. Again, with these, just take your time with them, please, right? Especially when they're long problems, just write them out on paper. That's the easiest way to do it. Or if you have some type of whiteboard like this on your computer, if you want to use Paint, whatever program that you have to write it out, that's the easiest way to do this, right? Just take your time with it. Don't rush through it, right? And what slide are we on? All right, let me just see what the next 2 slides are. All right, so this one over here, this is an example for you to try this one yourself. Again, just please don't forget, do PEMDAS, right? So parentheses first, exponents, multiplication, division, addition, subtraction, right? So it's almost time to go, right? What you guys are gonna do for the rest, right? Remember, we still have independent math class time. So you wanna still go ahead, finish this one here yourself. The next one here is just another example of how to evaluate something, right? Read through that example and then work on the rest of the practice through this activity here, all right? So this slide here, there's 20 slides. You've got about 6 or 7 slides to do on your own. Work on those, please, right? Tomorrow, I'm just gonna really quickly go through the rest of the slides, but then I'm gonna probably also have something else for you guys to practice that just has more work with working out these expressions, right? That's just really something that we need to practice because it's a skill that you guys just really want to try to master to make your lives a whole lot easier in the future. All right, so I'm going to end the recording here.